do you keep a floating city the size of a nuclear aircraft carrier from capsizing when it's pounded by monstrous waves taller than buildings during a perfect storm? It seems like an impossible challenge. Yet the US Navy routinely accomplishes this astonishing feat through sheer human determination combined with cutting-edge engineering and tireless preparation. The question is how? How can these behemoth ships shrug off the relentless battering of hurricane-force winds and towering waves that could swallow smaller vessels whole? The answer lies in a fascinating blend of advanced technologies, robust safety protocols, powerful forecasting capabilities, and brilliant naval design. Join us as we unveil the incredible suite of features, disciplines, and human efforts that prevent the Navy's largest carriers from surrendering to rough seas. But before we continue, we would like you guys to subscribe to the channel, like this video, and hit the notification bell icon so you do not miss out on any amazing and entertaining content. The physics of ship stability. Before we dive into the specifics, let's lay the foundation by understanding some key physical principles that allow ships to remain stable and resist capsizing, even when pummeled by towering waves. It all starts with buoyancy and the science of flotation. According to Archimedes' principle, any object immersed in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced by the object. For a ship to float, its overall weight must be less than the weight of water it displaces, having a lower overall density than water itself. But flotation alone doesn't prevent capsizing. This is where the center of mass or center of gravity becomes crucial. The lower a vessel's center of gravity, the higher its resistance to rolling over or heeling excessively during rough seas. US Navy designers maximize stability by concentrating heavy equipment, fuel, and ballast as close to the bottom as possible. Keeping this extremely low center of gravity is vital. The unique hull shape plays a crucial role as well. Instead of a rounded bottom, Navy carriers utilize a V-shaped hull designed to slice through towering waves rather than getting pushed around by them. Additionally, Navy ships employ high-tech ballast systems to actively control their buoyancy and keep them level. By shifting liquid ballast around, they can raise or lower their center of gravity as needed to counteract extreme leaning or listing in rough seas. Active stabilization systems. While good naval architecture provides inherent stability, modern stabilization systems give these huge vessels an amazing ability to actively counteract the extreme forces of rough seas. The laws of physics are no match for cutting-edge technology and brilliant engineering. One remarkable example is the ship's retractable fin stabilizers. Much like the wings or ailerons of an aircraft, these computer-controlled fins extend outward from the hull to provide counteracting forces that prevent rolling and pitching motions. Stabilizer fins are so effective that they allow flight operations to continue even in high sea states too rough for smaller vessels. Another powerful stabilization technology employed is the gyroscopic stabilizer system. These systems use rapidly spinning flywheels housed in vacuum-sealed spheres to create a powerful gyroscopic effect. Gyro stabilizers work in a similar way to a motorcycle rider, using counter-steering to prevent falls during high-speed turns. The force from the processing gyro applies torque along the ship's fore-aft axis, resisting any rolling motion. Damage control and ballasting. Despite all the preventative measures, there is always a chance that a mission could take an unexpected turn, requiring fast action to maintain stability and prevent capsizing. This is where the Navy's robust damage control systems, emergency training, and intelligent ballasting come into play. Thanks to their subdivision into numerous watertight compartments, Navy ships have an incredible amount of built-in damage resistance and reserve buoyancy. If one or more compartments starts taking on water due to damage, they can be sealed off while counter-flooding other sections to regain neutral buoyancy and trim. There are redundant pumping systems installed to expel any flooding and regain stability. Repair teams are highly trained to patch holes and plug leaks using special materials like aluminum shoring and wooden wedges. They practice these vital damage control drills constantly to maintain readiness. However, damage control is about more than just patching holes. It's about understanding and managing the ship's overall stability through intelligent loading. This is where the Navy's advanced hull stress monitoring systems and ballasting capabilities come into play. Taking into account factors like load distribution, ship speed, sea state, and hull integrity, onboard computers can direct the controlled flooding or transfer of liquid ballast to optimally shift the ship's center of buoyancy. This allows for precise adjustments to the ship's trim and stable weight distribution, preventing excessive stress and maintaining an even keel. Even if holed, a warship can recalculate its stability and adjust ballasting to remain upright through engineering. Forecasting and route planning. While naval architects have made these ships virtually unsinkable and stabilization systems give them a huge advantage, one of the biggest assets in the fight against extreme weather is comprehensive forecasting and route planning. With advanced meteorological tools, the Navy can quite literally steer around the worst storms. Every vessel has a dedicated team specially trained in the intricate study of meteorology, forecasting, and weather analysis. They utilize an array of sensors, satellite data, charts, and complex computer models to predict upcoming conditions days or weeks in advance. Weather data is sourced from Navy sensing equipment like radars, sat links, and global monitoring stations. Armed with this intel, route planners can adjust ship deployments and voyage plans to simply avoid regions predicted to experience hurricane-force conditions, high sea states, or impediments like ice flows. If a freak storm develops, ships can be rerouted around it well in advance. Maintenance and inspections. We can't talk about the amazing ways Navy ships overcome rough seas without highlighting one of the most vital factors: the people. Long before ever leaving port, countless man-hours of skilled work go into ensuring every hull, system, and stabilizer is up to spec and battle-ready. Teams of specialized inspectors and technicians scrutinize every component through a vigorous planned maintenance system. This regimented process covers everything from visual examinations and load testing of all mechanical and hydraulic systems to exhaustive computer diagnostics of machinery monitoring sensors. Hull integrity is closely examined for any structural defects using advanced non-destructive test methods like X-ray, ultrasound, and dye-penetrant inspections. Every single weld seam along the watertight bulkheads is meticulously examined. Communication and coordination between all crew members is paramount in these high-stress emergency scenarios. Everyone has a role to play and a set of procedures to follow without hesitation. Their quick thinking and decisive actions in the face of heavy storms can mean the difference between life and death. Future innovations. Even with the impressive stabilizing capabilities in place today, the Navy continually looks to push the boundaries of what's possible through new research and development programs. For instance, scientists are experimenting with smart hulls and adaptive structures that could automatically reconfigure their shape on the fly to account for changing ocean conditions. Advances in material engineering could lead to lighter and stronger composite hulls in the future as well. The reduced weight would make for easier stabilization, while the enhanced durability increases the survivability against punishing waves and impacts. AI and machine learning could also show intriguing potential for assisting human crews. By processing reams of sensor data in real time, an AI co-pilot could instantly make tiny adjustments to things like ballast, fin angles, and engine power to maintain the smoothest ride possible in turbulent environments. While still largely conceptual for now, these and other maritime advancements could one day make modern-day aircraft carriers seem as unstable as classic wooden sailing ships when faced with monster waves and extreme weather events. Now you know the incredible combination of human tenacity, engineering brilliance, and advanced technologies that prevent monster waves from sinking the US Navy's largest and most powerful aircraft carriers. Have any of you ever witnessed or experienced a naval vessel weathering an intense storm? What was it like? Share your stories and insights down in the comments. And if you enjoyed learning about these maritime marvels, give this video a like and subscribe to our channel for more awesome content. Tap the bell icon so you never miss an upload. Thanks for watching, and we'll see you next time.